Dear students, in this video we are going to discuss about de Broglie hypothesis. Actually, I am going to explain the concept of this de Broglie hypothesis. So for that, let me start from this point universe. Okay, so our universe is made up of two things. Okay, so the first one is radiation. The universe is made up of radiation and matter. Radiation and matter. So, for understanding, we can consider the radiation is nothing but light. The radiation is nothing but light. And then the matter is nothing but particle. Okay, particle. So what is that particle? Particle means if we consider any material, so if we divide into that, it will have the particles, number of particles. So particles means it is made up of the atoms like that. Okay, and then radiation means it is the form of energy. It is the form of energy. It is the form of energy, right? So this will be that. So universe is made up of radiation and matter. Okay, and then this light is having the nature of wave and then particle. Wave and then particle. That means the light has dual nature. The light, the radiation has dual nature. One nature is wave, the another nature is particle. The wave nature of light can be explained by the phenomenon of interference, diffraction, etc. Okay, so these phenomenons explained the wave nature of light. That means light is having the wave nature. Okay, and the same thing, the light is also having the particle nature. So that can be explained by the phenomenon of black body radiation, black body radiation, Compton effect, Compton effect, photoelectric effect, etc. Photoelectric effect, etc. Okay, so by means of this phenomenons we can understand that the light is having both the nature. Sometimes that means it has the wave nature as well as particle nature. Sometimes it behaves as a wave and sometimes it behaves as a particle, but it is having both the nature. So the light is having a dual nature. Okay, next when we come to this matter, okay, so matter means particle. So particle nature only it is having, but this actually the concept of dual nature of this radiation prompted de Broglie. Okay, prompted de Broglie to suggest the idea of matter waves. Okay, what is that meaning of matter waves? He said how this radiation is having dual nature, like that the particle is also having dual nature. Why? Because nature always loves symmetry. Nature always loves symmetry. Okay, so due to this, he tried to say how this radiation is having dual nature. Likewise, the particle is also having the dual nature. So the concept of dual nature of radiation prompted de Broglie to suggest the idea of wave nature of the particle. Wave nature of the particle. So he said this matter is also having dual nature. That is, sometimes it acts as the particle and sometimes it has the wave nature also. Okay, so this due to this dual nature only, due to the dual nature of the radiation only, prompted him to give that hypothesis that this particle is also having the wave nature. So particle in the sense, for example, electrons, neutron, proton, atom or molecules are associated with wave, are associated with wave. So the wave will be associated with the moving particles. Wave will be associated with moving particle. So now we can define that matter wave based on de Broglie's hypothesis. So matter waves, matter waves. So what he is trying to say, the waves which are associated with, which are associated with matter or material particle. So matter is nothing but material particle. Material particle are called as matter waves, or called as matter waves. So the particles are also having the wave nature, so this is the de Broglie hypothesis. Okay, so that how the radiation is having both the nature, likewise the particle is also having, that is the matter is also having both the nature, particle nature as well as wave nature. That means the wave will be associated with the moving particles like electron, neutron, proton, or atom or molecule. Okay, so these waves are known as the matter wave. So this concept has given by the de Broglie. That's what this hypothesis named as de Broglie hypothesis. Okay, so by means of this de Broglie hypothesis, he has given the wavelength for the matter wave. So if the wave is associated with this matter, means automatically the wavelength will be there for the matter waves. Okay, so what is the formula for the matter wave? That also he has given, that for that wavelength is given by de Broglie wavelength. De Broglie wavelength. Okay, so now we are going to find the de Broglie wavelength. The wavelength which are associated with the material particle is known as the de Broglie wavelength. So here he is going to take the proof of wave, that means dual nature of the radiation. So radiation is, what is radiation? Radiation is the form of energy. It's the form of energy, right? So this form of energy, if you divide this, that means it has the wave nature, so like that it is coming, right? So if you divide, for example, if you take the material, any material, if you divide this, what will happen? It becomes the particle, and then further if you divide the particle, it becomes the atoms, right? So in this way we can divide the matter or material, right? So same thing, if you divide this radiation, it will have the packets of energy, it will have the packets of energy. So that packet or bundles of energy is called a packet, or bundles of energy is called photons. Bundles of energy is called photon or quanta. Photons or quanta, right? So by using this photons or quanta only, de Broglie is going to get the formula for wavelength of matter waves. So he considered the theory of light. From the theory of light only, he has given this wavelength formula. So now we are going to consider that formula, that is from the theory of light, that is radiation. It has, that means here we are considering the photon. So now you consider the photon as a particle first. Consider a photon as a particle. Okay, both the nature it is having. First I am considering the particle nature. So according to the particle nature, the energy of the photon is, the energy of the photon, the energy of the photon is given by, as a particle nature, E is equal to mc square. This I am considering equation number 1. Here what is E? Energy of the photon, and then m is the mass of the particle. Mass of the particle. And then what about c? C is the velocity of light. C is the velocity of light. Velocity of light. So this he considered the photon as a particle nature. Next we have to consider photon as a wave. So the next step, this is the first step, we considered photon as a particle, and the next step I am going to consider photon as a wave. So consider the photon as a wave. photon as a wave. So here also we are going to write the energy of the photon. So the energy of the photon is given by, here which one we have considered as a wave nature. So what is the formula? E is equal to h nu. E is equal to h nu. So nu is the frequency. Frequency is the characteristics of wave. So when we consider the photon as a wave, that time the energy of the photon will be equal to h nu. This is equation number 2. Okay, so he considered both the nature of the photon, that is for radiation, right? So first one is E is equal to mc square when we consider the photon as a particle, and E is equal to h nu when we consider it as the wave. Okay, so now you compare this equation 1 and 2, that LHS is equal. Okay, in left hand side we are having the energy of the photon, in right hand side only the values are changing. So by comparing equation 1 and 2, I can able to write by comparing equation 1 and 2, that is mc square is equal to h nu. Mc square is equal to h nu. So in the previous case, h is the Planck's constant. See here, h is Planck's constant, Planck's constant, and nu is frequency of radiation, frequency of radiation, right? Next. So now by comparing this equation 1 and 2, I can able to write mc square is equal to h nu, right? So now momentum formula, already you know momentum. Momentum is represented by the letter P. P is equal to m into c. So mass of the particle into velocity of light. So now I can able to write this equation number 3 I am considering. So m into c square. How can I am going to write mc into c? Okay, c square is divided like this, which is equal to h nu. So what is the value of mc? That is the momentum P. So P into c is equal to h nu. Okay, and then P is equal to h nu by c. Okay, so as you know well, c is equal to nu into lambda. That is what is c? C is the velocity of light is equal to frequency into the wavelength. Okay, so nu by c. For example, nu by c is equal to lambda here. So according to that, P is equal to nu by c. I am going to write lambda, right? So from this equation I can able to write lambda is equal to h by p. Lambda is equal to h by p. So what is this? Lambda is the wavelength. Okay, h is the Planck's constant and p is the momentum. So lambda is related to the wave nature, okay, and the momentum is related to the particle nature. Momentum is related to the particle nature. He combined both. So lambda is equal to h by p. This is for the photon. So this equation, okay, can be applied for both photons as well as material particle. So this is the equation for photon, right? The same thing we can use for the material particle also. Same thing we can use for the material particle also. So how can we change this equation? If m is the mass of the particle, m is the mass of the particle, and v is the velocity of the particle. V is the velocity of the particle. Then momentum P can be written as P is equal to mass into velocity. Mass into velocity. Here m is the mass of the particle and v is the velocity of the particle. So that lambda is equal to h by mv. Okay, by taking the reference of photons, first he found the formula lambda is equal to h by p. From there he converted for the material particle also. This is for photon, he found, and same thing he applied for the material particle. So lambda is equal to h by mv. Okay, lambda is equal to h by mv. So this equation, this is the de Broglie wavelength. So the lambda is represented by de Broglie wavelength. So first I mentioned that we are going to find the de Broglie wavelength. So de Broglie wavelength lambda is equal to h by mv. So this is very important equation. Lambda is equal to h by mv, which represents the wave nature of the particle, right? So here I completed that lambda, that is de Broglie wavelength lambda is equal to h by mv. But we are going to discuss the same formula in terms of energy as well as in terms of voltage also. So let us go to that. So now we are going to discuss de Broglie wavelength in terms of energy. Okay, so what is the de Broglie wavelength actually? Lambda is equal to h by mv. This is the de Broglie wavelength formula, already we know that. But now we are going, here you see h is the Planck's constant, m is the mass of the particle, and v is the velocity of the particle. There is no energy term present in this. So in this formula, there is no energy term present. Okay, but now I am going to modify this wavelength in terms of energy. So already I said the matter wave will be associated only with the moving particle, only with the moving particle. If the particle is moving, then only the matter wave will be associated with it. If the particle is at rest, no waves will be associated with it. So the moving particle means it possesses the kinetic energy. It possesses the kinetic energy. So kinetic energy is equal to, what is the formula for kinetic energy? Half mv square. So energy is represented by E. So E is equal to 1 by 2 mv square. So the next step, I am going to multiply by m, that is mass of the particle, on both the sides. So the next step, multiplying by m on both sides, on both sides. So what will happen now? Here E into m, okay, and then half, here again one more m is multiplied. So m into m become m square v square, half m square v square. So now you listen, this 2 I am going to take here. So 2em is equal to m square v square. Okay, 2em is equal to m square v square. So this term I am going to take it here. So m square v square is equal to 2em. Okay, next one is taking square root. The next page I will go. So taking square root, taking square root. So m square v square become now mv, which is equal to, okay, root of 2em, root of 2em. Okay, so this is the value of mv. This is the value of mv. Okay, what is the de Broglie wavelength formula? De Broglie wavelength, that is lambda is equal to h by mv, h by mv. Now I can substitute the value of mv here. So what is the mv? Which is root of 2 em. Okay, so lambda is equal to h divided by root of 2 em. So now we derived this de Broglie wavelength in terms of energy, in terms of energy. So here h is the Planck's constant, and m is the mass of the particle. So now we derived this de Broglie wavelength in terms of energy. So that is the topic I have given already. So now this part is over. Next we are going to discuss the de Broglie wavelength in terms of voltage. Okay, so de Broglie wavelength in terms of voltage. Okay, the same formula in terms of voltage we are going to discuss. So already I said that waves will be associated only with the moving particle. So now I am going to give the voltage, that means potential difference, to the particle. Okay, so for example, charged particle. So what if for a, you are considering the particle which is charged, okay, whose charge is particle, whose charge is E, charge is E. Okay, so this particle is accelerated by giving the potential difference, the particle is accelerated. So how much potential difference we are going to give? Potential difference given is capital V. Okay, so for the particle, already the particle is having the charge E, and then the potential difference is given so that the particle will be accelerated. That is, it gets moving, accelerated, right? So now how the kinetic, what is the formula for kinetic energy again? Kinetic energy is equal to half m v square. Okay, so here the v is the velocity of the particle. How this kinetic energy is created? By means of the applied voltage. So the charge of the particle is accelerated by means of the potential difference. So kinetic energy E is equal to E into E, which is equal to half m v square. See, here two v's are there. This capital V represents the potential difference and the small v represents the velocity of the particle. So the same step I am going to do, that is multiplying by m, small m, on both sides. Okay, so what will happen now? In left hand side it will be m e capital V is equal to half m square v square, right? The same thing here, the 2 will come here. So 2m e capital V is equal to m square into small v square. Okay, so the next step will be m square v square is equal to 2m e capital V by taking square root, taking square root, taking square root. So the LHS will become mv, the RHS will become root of 2m capital V, E into capital V. So the de Broglie wavelength formula is lambda is equal to h by mv. Now substitute this mv value here. So the mv is equal to h divided by root of 2m e into capital V. Now you see the final result. Here capital V represents the voltage difference, potential difference, that is voltage. So the de Broglie wavelength expressed in terms of the voltage, in terms of the voltage. Okay, so this is the third step, de Broglie wavelength in terms of voltage. So now we have discussed what is mean by de Broglie hypothesis, and then what is the de Broglie with formula. Okay, and then how the de Broglie wavelength is expressed in terms of energy and then in terms of voltage. So now we have derived lambda is equal to h divided by root of 2 mev, that is de Broglie wavelength in terms of the voltage. I would like to substitute all the terms here, that is h, that is Planck's constant, is equal to 6.626 into 10 to the power of minus 34 joules again, and then mass of the electron is equal to 9.1 into 10 to the power of minus 31 kg, and then charge of the particle E is equal to 1.6 into 10 to the power of minus 19 coulomb. So except this voltage, remaining all the terms I substituted here. Okay, by solving this we will get the answer 12.26 angstroms divided by root V. Actually 1 angstroms is equal to 10 to the power of minus 10 meter, right? So 12.26 angstroms divided by root V. Why I solved this one means, in the next topic, in Davison and Germer experiment, we will use the formula. That is the reason here itself I just substituted all the values and I got this formula. Okay, so thank you everyone. Please watch this fully, and then if you are having any doubt, you can ask in the comment box. So thank you everyone.